I think I'm recording now. Yes. Okay, perfect. All right. So, okay. So for number 4, let's see. What was number 4? What was number 4? Sorry, I have to go up here. Yeah. So the x squared plus 1 minus 1. Okay, perfect. Right. So here's my function f. So f of x, it's this square root of x squared plus 1, and there's minus 1 outside. As I said, so you have to ask yourself if there's a division. Well, there's no division. Is there a square root? Yes, we do have a square root. So there is a square root. There's a square root. So then you have to solve wherever you have under the square root. Larger or equal to 0. Okay, and so what do we have under the square root now? It's x squared plus 1. Now, so we have to solve x squared plus 1 larger or equal to 0. All right. So I mean, if you try to solve for x here, let's say you subtract 1 both sides. So this is like x squared, x squared larger or equal to, so 0 minus 1 is -1. So here, guys, you can see that so x squared is larger or equal to -1. I mean, this is because the square of a number is always positive or 0, right? So this is, so this x squared, right? This is always positive or 0. Okay. Oh, okay, Lorda. So this x squared is larger or positive or 0, and of course, if it's positive or 0, then it's it's larger than -1, right? So x squared, because x squared is positive or 0, then it's always larger than -1. Oh, you are not hearing again, Lorden. Well, I guess, well, probably it's a problem with your, oh, okay, you can hear me. Okay, perfect. So because x squared is positive or 0, then it's always, then x squared is always larger or equal to -1. To -1, right? So this inequality here is true for any x, right? It doesn't matter your x squared, this is always larger or equal to -1. Okay, so my input x can be any real number. So the input x can be any real number. Okay, so I mean, it makes sense because you see, guys, here what we have under the square root is x squared plus 1. I mean, x squared, it's positive or 0, and plus 1, well, if you have something positive or 0 plus 1, it's going to be again positive, right? So this x squared plus 1, this is always positive, right? So what we have here under the square root is always positive. So there's not actually, we don't have to exclude anything here, because for any value of x, whatever you have under the square root is going to be positive, right? And so our answer here makes sense. So the input x can be any real number. And so find answer. So the answer, so the domain of f of x is Well, I mean, if you have your, so it's going to be the whole number line, right? So it's just a negative infinity to positive infinity. It's any number, so it's the whole number line. And yeah, is there any question, guys? All right, so the last one, this one I think it's kind of tricky because it's like you have like a mixture of I mean we have both like a division and a square root, so we have to two equations to solve, right? So number 5, I think it's f of x equal to if I'm not mistaken, is 1 over square root of 4 plus x minus 2, right? So first, so we have a division, right? So we have a division, so this is, of course, there's a quotient here. So we do have a division. So then we have to solve the denominator equal to 0, and then exclude the answers from, the domain. The answers. Okay, so let's do the divisions first. So we have to solve the denominator. So what's the denominator? Well, the denominator is the whole thing here in the bottom, right? Is this whole it's this whole square root of 4 plus x minus 2. So we have to solve square root of 4 plus x minus 2 equal to 0, right? So the denominator is the whole thing. So that's why we need to include this minus 2 here, right? Because it's in the denominator. All right, so we have to solve this for x, of course. So what we can do is there's this minus 2. You can add plus 2 both sides, right? And so there'll be square root of 4 plus x equal to positive 2, right? This minus 2 plus 2 cancel out. Now, I have this square root of 4 plus x equal to 2. So we have to get rid of we want to solve for x, right? And the thing is, my x, it's under the square root. So I need to get rid of this square root, right? This is my x is under the square root. So I need to get rid of the square root, so then I can get the value of x, right? So how do we get rid of the square root? Well, we apply squared. Yes, absolutely, Eliani. Yes. So we squared. And if you square the left side, you have to square the right side. Okay. So once you square it, then that will be 4 plus x now on the left equal, square both sides. Absolutely, Lorden. So equal to 4 on the right side. Okay. Again, so this square here, it cancels out. This is square root, right? So now it's like 4 plus x equal to 4. Just solve for x, of course. So we just subtract 4 both sides. So then this is like 4 minus 4. It cancel out. And so my x, 4 minus 4 on the right side, it's also 0. So it's just x equal to 0, right? So what we are saying here, guys, is that we have to exclude x equal to 0. So first thing to do, so we need to exclude x equal to 0 from the domain. Okay. Now, the bad news is that we don't have only a division here. We do have also a square root, right? We do have this, there's this a square root here, right? There's a square root here, right? And again, if you have a square root, then you have to solve wherever you have under the square root larger or equal to 0. So we need to solve. So this is the step 1. In the step 1, we had to deal with this division. Now, the step 2, we have to solve. So step 2. So there is a square root. So we have to solve what's under the square root larger or equal to 0. So don't forget the can be equal to 0 here. So it's larger or equal to 0. So what do we have under the square root? Well, it's just 4 plus x. Okay, so that here we don't really care about the -2 because what's under the square root is the 4 plus x. It's only the 4 plus x. So it's 4 plus x larger or equal to 0. So here we have to solve 4 plus x larger or equal to 0. You can just subtract 4 from both sides. So then my x is larger or equal to 0 minus 4. It's -4. And this 4 minus 4, of course, goes away here. Anyway, so my input x must be larger or equal to 0, right? This is larger or equal. So it can be equal. So larger or, so it can be equal or equal to -4. So now I can answer the question, right? So the answer to the question would be, so let me use a number line here because it will be probably useful. So I have -4, I have sorry, negative infinity, I have a positive infinity. I'm gonna put the -4 somewhere here. And don't forget from the first step, we said we have to exclude x equal to 0 from the domain, right? So I need x equal to 0 because I have to exclude it from the domain. So I'm gonna put 0 here somewhere. Here's my 0. Anyway, so first, what we are saying here is that, so with this inequality here, is that my x is larger or equal to -4. So x larger or equal to -4, so that will be the right side of -4. So x larger or equal to -4. So that will be the right side of -4. Okay, do we include -4? Yes, because it can be equal to -4. So I'm going to include the -4. Okay. Now, from the first step, we said we have to exclude the x equal to 0, right? That comes from the division, right? So we said we have to exclude x equal to 0. So that here at 0, we have to exclude this x equals 0. So I'm going to use parentheses here around 0 because we have to exclude it. Okay. So from the step 1, remember, so we had to exclude x equal to 0. So find answer. So the domain of f of x is, so -4 to 0. -4 is included, 0 is excluded, and then union, and then we start again at 0, not at +1, not at 0.5, not at 0.1. We have to start again at 0, but of course 0 is excluded to positive infinity, and that will be the final answer.
Professor, can you
yes
remember again number 4? How we determine
number 4?
Yeah, how we determine negative infinity and positive infinity from -1?
Number 4, you mean this one here, right?
Yes.
Yeah. So here, what I was saying. So we said we have to solve what's under the square root larger.
I mean, I can understand the equation. Like, I'm not clear here. Like, because x square is positive or 0, then x square is always larger or equal to -1.
Yeah, because so what's the inequality here? The inequality says like your x square must be larger or equal to -1, right? That's the inequality,
Yes,
right?
yes.
Then
I understand this part. Yeah.
And you have to solve for x. Now, what I'm saying is my x square is positive anyway because it's a square. I mean, x squared, this
Yeah.
it's positive, right? Because of
it's
the square.
positive. Yeah.
So it's gonna be larger than -1 anyway, right? because it's positive.
Yes.
So it doesn't matter the value of x. For example, x wherever, let's x -5 or -10 or +10 or whatever value of x, this thing here on the left side, it's going to be always larger than -1 because it's always positive, right? This thing is always positive, or 0 actually, always positive, right? So if it's always positive, it means it satisfies the inequality. So it means that any value of x is going to satisfy this inequality because it's positive, so it's automatically larger than -1. So it's always, this inequality is always satisfied, right? This is always satisfied because my x squared is positive anyway. So it's going to be larger than -1 anyway, right? That's what I'm saying here.
Okay.
This is always, this inequality is always satisfied for any x, Okay, so it doesn't matter the value of x here, this inequality is going to be always satisfied.
Okay, Professor, thank you.
Sure. Is there any other question, guys? So yeah, for this number 5, the last one here, so this will be the answer. -4, 0 excluded, union with 0 excluded, again, positive infinity. And again, guys, remember, you have to go from left to right. This is really important. I mean, it's really important, right? Okay, so if is there any question? Let me check the chat if I missed something. No. Okay, perfect. All right, so that's good. All right, so then so this is like the problem number 4 in the homework, the last problem, where you have to find the domain of a function using equations. So now next we're gonna find the domain of a function using graphs, right? Because remember, guys, we said we can describe functions using graphs. So now next we're gonna find the domain. I'm gonna show you how to find the domain of a function using graphs. So so next, so we're gonna find a domain of f of x using graphs. Okay. So okay, so let me do an example. I'm going to show you how to find the domain if you have the graph of some function f. So an example. Okay. Example 1, let's say. Let's do a couple of examples. So my first example is the following graph. So this is the graph of my function f. So this is x, of course. This is my y. Of course, x here, it goes like from -infinity to +infinity. Same for y-axis. This is supposed to go from -infinity to +infinity. Let's say this is 0 somewhere here, 1, 2, etc. This is 1, 2, and -1. Anyway, so let's say the graph of f of x is the following. So I'm gonna have like let's say here. Okay, so let's say this is the graph of f of x. Graph of f of x. Okay. So the question, of course, that's the graph of f of x. You can check that this is a graph of a function because it satisfies the vertical line test. But anyway, so the question here is actually to find domain of f of x. Okay. So again, if you want to find the domain of f of x, you want to find the set of all x values for which the function is defined. Okay, so this is the set. Again, the domain, that's the set of all x values for which the function is well defined. The function is well defined. Okay. All right. So first thing to do is, so step one. So I'm going to do, so there are a couple of steps here to find the domain. So step one, first thing to do is, well, we always go from, so we go from left to right. Okay. So we go from left to right. Okay, and what we do, guys, so we're gonna use vertical lines to find the domain of f of x. So for example, if my input x is, let's say, negative 2, what will be the output y? If my x is negative 2, what will be the output y? Well, what I'm supposed to do to find the output y is, as I explained yesterday, you're supposed to draw like the vertical line passing through the negative 2, right? But then this vertical, no, actually, Lorden, this vertical line doesn't intersect the graph, right? So there's no intersection with the graph. And so if there's no intersection with the graph, it means that the output y is undefined because you don't intersect the graph. So what I'm saying is, if my input x is negative 2, then there's no output here. So here there's no output because it doesn't intersect the graph. There's no intersection with the graph. So there's no output. Well, if you take, for example, negative 1. So if you take negative 1 and you take this vertical line, so what will be the output? Well, here, negative 1, no, Eliani, actually, because you see, so if you take the vertical line passing through negative 1, it's going to intersect the graph here, right, at this point. So it's going to be positive 1. That's positive 1. I said yeah, so I'm talking about x equal to negative 1. So so if my x is negative 1 and I want to find the output corresponding to x negative 1, you draw the vertical line here, intersect the graph, the red graph at this point, right? And the corresponding output y is positive 1. Okay, so what I'm saying is, if you have some value of x, some input x, okay, and you want to find the corresponding output, you use a vertical line. So if your vertical line intersect the graph, then you're going to have some output y. If it doesn't intersect the graph, then there is no output. Okay, so then the function is not defined at that point. So to find the domain of the function f, you need to use the vertical lines. And whenever your vertical line intersects the graph, then the input x would be in the domain. Okay, so the idea here is, so we're gonna use vertical lines. So if your vertical line intersects the graph, if the vertical line intersects the graph, then the value of x is in the domain. So if the vertical line intersects the graph, then x is in the domain. Then the value of x is in the domain. Again, that's because if the vertical line intersects the graph, it means that there is a corresponding output. And so the function is well defined at that x. If there is no intersection with the graph, it means that there is no output. And if there's no output, it means that the function is undefined, right? If there's no output. So what I'm saying, guys, is that, so I'm gonna go from left to right. So I'll start at negative infinity here. I'm supposed to start from negative infinity from the left. So when you start from negative infinity and you take this vertical line here, there's no intersection, right? There's no intersection. You arrive at -2 and still there is no intersection with the graph. So when do we intersect for the first time the graph? Well, we intersect the first time the graph at -1, right? Here, -1. If you take this blue line, this vertical blue line is going to intersect the graph. Okay, so then -1 is in the domain because the vertical line passing through -1 intersect the graph, the red graph. Okay, and then if you take some value here just right after -1, well, you take a vertical line here, is going to intersect the graph. So this thing here is going to be in the domain. So here it's still in the domain. This is still in the domain because if you take a vertical line, it's going to intersect the graph, right? Now you arrive at 0. So at 0, if you take a vertical line, is there an output? Do we have intersection with the graph? Well, so just to remind you guys, if you have this circle, so the circle means that the point is not, this is not included in the graph, right? Not included in the graph. Okay, so when you arrive at 0 and you take this vertical line passing through 0, there will be no intersection with the graph because you're going to have like these two circles and they don't really count because they are not included in the graph. So at 0, we don't really have an intersection with the graph. So the 0 is not in the domain. Okay, so 0 is not in the domain. It's not included in the domain. So I'm going to use like, I'm going to use like parentheses for 0 because I have to exclude 0, right? And then, we continue, right? So here after 0, right after 0, if you take a vertical line, you're gonna have an intersection, right? So there's an intersection, so that will be in the domain. So here's going to be in the domain, What about +1? Is it in the domain? Well, if you take a vertical line passing through +1, well, here there's no, you see here, there's no intersection because that's not included in the graph, but still you have an intersection at this point here. So +1 is included in the domain. So I can include +1 in the domain. There's no problem with +1. And then I arrive at +2. And then, but then at +2, if you take a vertical line at +2, there will be no intersection with the graph. So +2 is supposed to be excluded from the domain. So I need to exclude this +2, right? And then after, of course, after +2, there will be no intersection. So it's not in the domain of the function f. Again, guys, domain means the set of the x values for which the function is well defined. Okay, so if you don't have an intersection with the graph, then it means that the function is not defined at that point. So here, if I take a blue line here, then this x here, the function is not defined at this point because there is no intersection with the graph. Okay, so what's the domain then for this graph? Well, the domain, it starts at -1, right? Because we do have an intersection at -1. If you take a vertical line at -1, there will be an intersection with the graph. So -1 is included, as you can see. And then we said you go to 0. Well, there's 0, there's a problem because if you take a vertical line there will be no intersection. So 0 is excluded from the domain. Then after 0, it's going to be included in the domain because you're going to have intersection with the graph, etc., until you arrive at 2. Yes, Darian. So the answer, absolutely, it's so the answer here would be -1, -1 included, 0 to 0, 0 excluded, and then from 0 to +2, +2 excluded. So probably I'm gonna write down the answer right here. Probably just first here. So the domain. So the domain is -1 included. Then from -1 to 0, 0 is excluded because there is no intersection with the graph, union. And then you start from, again, from 0, excluded, and then from 0 to actually to 2. As I said, a +1, there is no problem at +1 because there is an intersection, right? So +1 is not a problem. So you go from 0 to 2, and 2 is, of course, is excluded. So yeah, so the answer, as Darian said, so -1, 0. So final answer. So domain of f of x is, so -2 included to 0, excluded, and then from 0 to +2, +2 is excluded. Again, +2 is so this is so -2 is included, because -2 is included because if you take a vertical line passing through -2, it will intersect the graph, the red graph. 0 is excluded, and the same +2. So they are both are excluded, right? Because again, same reason. So anyway, so you see how we can find the domain. So all you have to do, guys, is to use the vertical lines. And so whenever your vertical line intersect the graph, it means that the function is well defined at that point. So then the point would be in the domain. If you have intersection, then it's in the domain. If you don't have intersection, then it's not in the domain, right? So that's the idea. So let me write it down again here for you. So the idea is, so if the vertical line, so if vertical line intersect the graph, then x is in the domain. It means that the output, the corresponding output y is well defined. There is an output, there's an output y, then x is in the domain.
Professor,
And if not, yes.
Yes. Why did you put a bracket on -2?
Yeah, -2 because as you can see here, sorry, a -2 or -1? Oh, sorry, it's -1. Sorry, thank you. It's -1 actually. I meant -1, not -2.
Oh, okay.
Yeah, because yeah, you see here my answer. Sorry, because I went down and then I forgot it was -1. Yeah, so it's -1 because -1. You see here's my graph, and so if you take this blue line at -1, you're gonna have intersection, right? With the graph.
Question.
Thank you. Yes. Yes.
So then why wouldn't we put bracket 1 to 2, because it intersects with 1?
Yeah, but the thing is, yeah, that's the thing. Here, so you suggest to like to say like -1, 0, a union like 0, 1
Yeah,
included.
Bracket
then,
-1 to 0. If it's
yeah,
already
but that's
0,
actually, yeah, it's the same thing. So because you're gonna include 1, right? 1 is included, right? So if 1 is included, then you don't have to split the interval 0 to like 0, 1 included, and then 1 included to 2, because if 1 is included, then you don't have to split this interval 0, 2.
So I don't have to include the 0 to 1 because it's already included in negative.
Yes,
1,
it's there. Yeah, it's there, right? It's in the 0, 2 here. Yes, 0, 1, it's in the 0, 2.
So then, okay, so I have a question, sorry. So do I write a bracket -1 to 0 and then bracket 1 to 2?
No, so here's the answer again. This is, well, I mean, this is acceptable, but I would say this is the best way to write the answer. It's just -1 to 0 and then union 0, 2. Okay, I mean, this is correct, but this is correct. I guess that's what your suggestion, right? This is the 0, 1, and then union 1, 2, 1 included, right? This
No,
is correct.
Just okay, because you know it says bracket -1 to 0. It's already included that 0 is not part of it. So why do I have to repeat 0 to bracket 1 if I'm basically writing it twice? Do you get what I'm trying to say?
No, but this is, I mean, they have two different intervals here. This is -1, 0, and this is 1, 0. There are two different intervals. The thing is, if you write like -1, 1, well, then it means that the 0 is included, right? If you write like -1, 1, I don't know, included, both included, then it means that the 0 is there, but the 0 is not, right? It's excluded.
Oh, okay. Thank you.
I mean, does this answer your question? I mean, the -1, 0 and 0, 1, they are two different intervals, right? You agree with me, right? I mean, you know, on your number line, you have -1, you have 0, you have 1. And so when you say -1 to 0, this is -1 to 0, and 0 to 1, this is it's a different interval, right?
Yeah.
This is right. There are two totally different intervals, right? So yeah. And as I said, you don't have to stop at 1 here, because 1 is included anyway. So it's included in this 0, 2. So you don't really have to stop at 1 because it's there. It's in this interval 0, 2, right? 1 is there, right, in the interval 0, 2. So you don't really have to stop at 1, right here. You don't really have to stop at 1. It's still correct, but it's not really. I don't. It's not really good answer because, as I said, so the 1 is included. So if it's the 1 is included, you don't have to stop at 1 because right after 1, it's still in the domain, right? If you take 1.1, it's still in the domain. So you just you can just continue after 1, and then you have to stop at 2 because after 2 there will be no intersection. So you really have to stop at 2. But you don't have to stop at 1 because 1 is included anyway. And then after 1, you can continue, right? From 1 to 2. Is there any other question, guys? We're gonna have more examples, of course. This is like just the first example. Yeah, so the answer, yeah, thank you. So because the answer is actually -1, it's not -2, it's -1, 0 union with the 0, 2. So this is supposed to be capital U, of course. This is a capital U. This is a union, right? This is capital U. All right, so let's take another example. All right, so this is first example, second example, and then we're gonna have exercise. So don't worry, guys. So we're gonna have we're gonna have an exercise so you can practice. Example number 2, because I'm gonna do another example because there's another notation I wanna introduce. So again, this is my x-axis, and this is like my whole number line. It goes from -infinity to +infinity, and this is my y-axis going from negative to positive. Anyway, so the graph of my f of x, so here's my -1, 0, etc. And then let's say my graph is this one here. And there is an arrow here. So let me just explain this notation. So the arrow here means that actually the graph actually doesn't stop. It continues all the way down, right? So the arrow means that the graph, it doesn't stop. It continues all the way down. So it doesn't stop. Okay. So what I'm saying is that the arrow here means that the graph will go all the way down, right? It doesn't really stop. Okay. All right, so I need to find the domain as usual. So find the domain. So I'm gonna start at as usual from left. So at negative infinity. So here at negative infinity, there'll be no intersection. So it's not in the domain, etc. Let's say here's -2, for example. All right, so etc. here. So there's no intersection. I arrive at -2, still no intersection. So it's not in the domain. And now I arrive at -1. Do we have intersection at -1? Yes, we do. There's an intersection here with the graph, which means that -1 is in the domain. So my -1 is in the domain, and I have to include -1 in the domain. So I'm going to use the bracket at -1, right? So we start at -1, domain starts at -1. So let's see what happens next. So next, we're going to still have intersection, still have intersection, still have intersection, etc., etc. And actually, as I said, because of the arrow, it means that the graph is continuous, it doesn't stop. So it means that positive infinity, you can go all the way to positive infinity, and you still have intersection with the graph, right? You know, like here, 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 etc. So you can go all the way to positive infinity, and still you have intersection. So my domain would be like from -1 included, you can go all the way to positive infinity, and you still have intersection with the graph, right? So the answer in this case, so the domain of f of x is actually -1 included, all the way to positive infinity. And remember, positive infinity is always excluded anyway. It doesn't matter if you know, it's always excluded, right? So this is included because we do have intersection of the graph, and this is always excluded anyway, right? Any question about this example?
I have a question.
Please, yeah.
But it's about a different example. If that's okay. So I was looking at the homework. I'm gonna share my video so I can show it.
Okay. I guess you can share.
I can't tell if you guys can see me because I'm on my tablet. Can you? Let's see.
I don't see anything yet.
Oh, you guys can see me?
Yes.
Okay.
Yeah.
So
okay, I don't see you.
Yeah.
Okay,
Oh, darn.
I can. Okay, I can't see you because I'm sharing the board. I need to stop sharing the board.
Oh.
And I'm afraid that I'm gonna lose the board if I.
Oh, okay. I'll wait then.
Okay. But I mean, you're talking about the homework, right? I can.
Oh, you can pull it up. It's
Yeah.
There's a graph, and
which one?
it's graph H actually.
Oh, okay. Yeah, I'm looking
I'll
at.
stop sharing my video. You see how the graph has the open circle, and then right
Yes.
above it, it has the closed one. So
Yes.
for the domain, like, what would you put for that? Like, do
Yeah, so
you exclude 3, or like, I don't know.
Okay. So if you have an open circle, that's excluded, right, from the graph. Or open circle. So if you have an open circle, that's excluded from the graph, right? And the full circle, that's included, right? It's in the graph. So this is excluded from the graph. This is included in the graph. So like at positive phi, like, so this is homework, right? So you have like your so you have like your positive phi somewhere here, right? And then you have your graph like this, right? Something like this here. All right. So let's see, I am like in the neighborhood of phi. So like I am somewhere here, you know. So we do have intersection here, right? This is an intersection. So it's in the domain. This is in the domain. Here it's in the domain. Well, I arrive at P. Here, there's no intersection because that's excluded. But the other point here, it's a full circle, so it's included in the domain. Sorry, included in the graph. So if it's included, it means we do have intersection, right? So if we do have intersection, it means that the phi is included in the domain because we do have intersection, right? Because your vertical line intersect. It doesn't matter if you have this empty circle, because you still have intersection at this point, and so your positive phi is included in the domain. So you can continue with your domain here.
So right? For both points, I will just put a bracket then?
You don't have to put a bracket. That's the thing. So because you don't have to stop at phi, right? Because there's no problem with phi. We just said the phi is in the domain, right?
Okay, so just continue as one whole point. Yeah,
yes, just continue with your domain. You don't have to stop at phi. So I don't know, let's say
so it's
for example,
-4 or 5. That would be it.
Yes, that would be the answer. Yes. Okay. That's the thing. Yes. Mm-hmm. I know it's kind of tricky, but I mean, if you give it like a thought, then yeah, it's because you do have intersection at phi, so you don't have to stop at phi, right? Because after phi, you still have intersection, so just continue with your domain. Yes.
Okay, thank you.
Sure. Is there any other question, guys? Otherwise, here's an exercise for you, so you can just practice a little bit. All right, so exercise. So we need to find the domain. Yeah, so that's actually a good point. So in the homework, guys, there are like 2 graphs, I think. Let me see. Yeah, there are like 2 graphs, and you need to find the domain of the 2 functions, of the 2 graphs, right? So yes. So yeah. So please find the domain. So let's do like the 2 graphs here. All right, so let's say here's my graph. All right. So that's the first function. Second function. Right. So let's say this is f of x and this is h of x. Right, guys? So please try to find the domain of f and h. Okay, so let's say you have 5 minutes to think about this exercise.
Professor, what's the this is Sean. What's the number on the y-intersect on number 1?
The number under sorry if it's which one? Excuse me, which one?
What's
the under.
What are the numbers on the y-intercept?
On the y-axis, it doesn't really matter. because the domain, it's all about the input x, so it's about the x axis. So on y, I mean on the y axis doesn't really matter what values you have on y. Okay, because the domain, it's about the x, right? So it's about the x axis. Review, let me see. Sorry, -2, -1, 0, 1, 1, 2. Let me see. Yes, yeah, you're correct. Absolutely. Positive. Yes, 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 review. Correct. Yeah, so that's the idea. Actually, the domain, it's all about x, the input x, the x axis. Now next, the range. The range, we're gonna so we're gonna see what happens with to the output y. Lord Daniel's saying, oh, actually, Rabiul, I think you, sorry. -2, -1. But I think, guys, you missed the, actually, sorry, Rabiul, I think, well, sorry. But you guys, I think you forgot there's an interval, from, I mean, you still have intersection right after -3. So actually, the right answer, so it's not -2, -1. So it's going to be -3 and -1, and both -3 and -1 excluded. So yeah, I'm sorry, Rabiu. So your answer is not correct, actually. Same for you, Lorden. Yeah. So yeah, we start at -3, -3 not included. But yeah, for number 2, -∞0, 1, 2. So let's see, -∞0. Yes, Rabiul, for number 2, I can say it's correct. Yes. Yes. Eliani, you said, actually, no. So it's -∞0. Your Eliani, your first interval is correct, but your second interval is actually incorrect, because between 0 and 1, there will be no intersection. So so the second interval should be 1, 1, 2, not 0, 1, 0, 2. Because between 0 and 1, there will be no intersection. Yes, Rabiu, now it's correct. Yes.
For our homework, can we do corrections to increase the grade?
Sorry, I didn't hear. Correction to what? To the 2 problems here?
No, for our homework, are we allowed to like send you corrections?
Well, because it's due Friday night, right? So yeah, I mean, if you have a question about the homework, I can answer it, but what do you mean by corrections?
Like if we get a problem wrong, that's gonna be minus a point. So is it possible for us to like redo it and send it to you the correct way to increase?
After you submit the homework, right?
Yeah.
Okay. Corrections. Well, probably no. because it'll be probably too because you are like
It's all right.
25 students,
Mhm.
then it would be too much work for me. It's like intensive course, and every day I have now like to grade homeworks. But okay, well, I don't know. No, the answer would be no. No correction.
And at what time we have to submit the homework on Friday?
Oh, Friday. It's on Blackboard, but I think it's around before
After
midnight.
class? Okay.
Before midnight. Yeah, before midnight.
Thank you.
Sure. All right, guys. I guess probably you're done with the exercise. So
Professor,
for
can you
number,
repeat that one again? Because I'm a
which
little
one?
confused. Find the dominant in that one.
This exercise.
Yes.
I didn't solve anything yet.
Oh, that's
Oh no, yeah, I'm gonna do it now. Yes. Okay, unless any well, I guess you are done. So for number one, guys, we start, I guess, from the left, as usual. So here there will be no intersection, no intersection, no intersection, and then you arrive at negative v. Well, at negative v, there is no intersection, right? But right after, in a neighborhood, when you are very close to negative v here, there will be an intersection, right? There will be an intersection here, right? Just right here. So, which means that right after negative 3, we're gonna have x would be in the domain in the domain of the function f. So we start at negative 3, but negative 3 it's not included, right? Because of the circle, right? So this is negative 3 is actually excluded. So we're gonna go all the way. So now negative 2. Well, the question is a negative 2 a problem? Well, the answer is no, because if you take this vertical line here passing through negative 2, you're going to have intersection right here, right? There'll be an intersection right here. So which means that negative 2 is in the domain. So we don't have to stop at negative 2, right? We can just continue here all the way to right. So this is here, we're going to have intersection. So we can continue all the way to negative 1. But then at negative 1, there will be no intersection, and we have to stop at negative 1, because right after negative 1 there will be no intersection, right here. Right after negative 1, like between negative 1 and 0, there will be no intersection, right? So we have to stop at negative 1, and negative 1 must be excluded, right? Because we have this empty circle here. So this is negative 1 is excluded. And then at 0, we're gonna have intersection again, right? So here at 0, it's clear, it's obvious, we're gonna have intersection at here at this point. So 0 is in the domain. We're gonna continue until we arrive at 1. Now, is 1 a positive 1 a problem? And the answer is yes, because if you take this vertical line here passing through positive 1, there will be no intersection. So we have to exclude the positive 1. And because of that, you're going to use a parenthesis at positive 1. So we have to exclude the positive 1. And then right after positive 1, like positive 1.1 or 1.001 or something, we're going to have, again, intersection, right? Right after positive 1, we're going to have intersection. So right after 1, we're going to have intersection. And of course, we need to exclude the positive 1 all the way to positive 2. And at positive 2, we have intersection. So that's included in the domain. So the answer for number 1, so that will be negative 3 excluded. And then we said -2, we don't have to stop at -2 because we do have intersection. Then we can go all the way to -1, excluded because, right? I mean, because there's no intersection at -1. And then union, -1, between -1 and 0, there's no intersection, right? So, and then we start again at 0, 0 included because we do have intersection. And then we have to stop at 1. So we have to exclude 1 and start again at 1 because right after 1, we're going to have intersection. But still, 1 is excluded all the way to 2, 2 included. Right? Does this? I hope this makes sense to you guys. I hope it's not really something mysterious here. Anyway, again, please feel free. Yes.
It's a little complicated. It's fine.
It's a little bit complicated. Yeah, I mean, with a little bit of practice, it's not. It's gonna be not that complicated, I guess. Number 2. Same thing. So we start from the left, and when you start from the left, I mean, you start at -infinity, right? This is like your whole number line, and your whole the number line goes from -infinity to +infinity. So here, when you start at -infinity, well, we do have intersection because I mean, this graph here actually it doesn't start right here. It actually is it's a continuous graph, right? It goes all the way right to -infinity. So we're gonna have intersection. So -infinity, right? We start at -infinity. There'll be intersection all the way to intersection here, intersection here. So from -infinity to 0, but then we have to stop at 0 because there's no intersection at 0, and so we have to exclude 0, right? So 0 excluded, and then between 0 and 1, as you can see, if you take a vertical line between 0 and 1, there'll be no intersection, right? So, but we're gonna have intersection again at +1, right? So if we take +1 here, we're gonna have intersection at this point. So so then +1 is included in the domain. So we're gonna use bracket all the way to 2, which is of course excluded, right? So anyway, so the answer for number 2, so that would be -infinity. Well, as I said, -infinity, it's always excluded because it's not a finite number. It doesn't count. -infinity to 0, 0 excluded, and then union 1 included because we do have intersection at 1, and 2 excluded because there is no intersection at 2, right?
Professor, wait.
Excuse me?
Hi, Professor. Yeah.
Yes.
Why is -infinity excluded?
Yeah, as I said, the thing is, because when we were talking about the domain, we were talking about the values of x, and the x is supposed to be a real number. And the thing is, infinity is not a number. It's not a finite number. It's not considered as a number. Infinity is not a number. All right, so it's just a symbol for something which is actually do not exist. But yeah, it's not. It's just because it's not a number. Okay, that's why it's always excluded. I mean, when I say it's not a number, it's not a number because when I mean 1 million, it's not infinity. 1 million is a large number, but infinity is when you it's not a finite number. It's not really a number, infinity. Anyway, okay, so guys, next, so this is for the domain, and then we're almost done. So we are done actually with the domain. Now next, it's the range. Okay, so now we're gonna see we're gonna check the outputs y. So next, so we are done with the domain. Now we know how to find the domain when the function is described by an equation or by a graph. Now, so next is it's the range. So number 2 now. So the range of f of x. All right, so the domain, it's about the input x, right? So then as you can guess, the range, it's about the output y, right? So the definition of the range, so the range would be the definition here. So the range is going to be about the outputs y. So the range of a function f is just the set of all y values. The range of function f of x, is the set of all possible outputs y. Okay. In other words, all the values, all y values, the function, all the y values the function attains. Okay. So so the range is about the outputs y. So that's the set of all possible outputs y. Yeah, so then of course the question now is, how do we find the range? Let me just write, so here, so this is all outputs y of the function. Okay, so now the question of course is, how do we find the range? So the question, and so in the homework, actually there is actually, I think there are like there are some questions about the range. So you have two graphs, and for both graphs you have to find the domain and the range. Okay, so question is, how do we find the range of f of x? So let's do the graphs first. So using graphs. Okay. So I guess let me do an example. Okay, so, and I'm going to show you the example how to find the range. So this is very similar to the domain, right? So the domain, we use like, you know, vertical lines, and whenever your vertical line intersect the graph of f, then your input x is, your x is in the domain, right? Now for the graph, for the range, we're going to use horizontal lines, and whenever your horizontal line intersect the graph, then the corresponding value of y is in the range. Okay, so so it's very similar to the domain. So okay, so an example. All right, so let's see here. So now I need to put some values on the y-axis, because as I said, the range is about the outputs y. So let's see here. This is my x-axis. This is the y-axis. Of course, here's the positive infinity, negative infinity. And so let's say the graph of f of x is the following. So I'm going to need some value of on the y-axis, -1 here, -2, 0 here, and then this is 1, 2, let's say this is 3, and this is 4. All right, so let's say the graph is of f of x is the following. So let's say we start from you know, somewhere here. -2 here, and then let's say you have something right here, and right here. Okay, So this is the graph of f of x. All right, guys. So how do you find the range? For the range, you go from the bottom to the top. Okay, for the domain, from left to right. For the range, you go from the bottom to the top. So step one. So I would say, so you have to go from the bottom to the top, and use horizontal lines. Okay, and so if your horizontal line intersect the graph, then the corresponding value of y is in the range. Okay, so if the horizontal line intersect the graph, then the corresponding y is in the range. Otherwise, it's not in the range. So there's no intersection. Then y is it's not in the range. Here there's intersections, and then y is in the range. All right, so we're gonna start from the bottom. So from the bottom, I mean the bottom of the y-axis. So here in the bottom, I'm gonna use again, as I said, I'm gonna use the horizontal lines. So I'm gonna start at negative infinity here. I'm gonna use the horizontal lines. So here, obviously, there's no intersection, right? Let's see. Well, here, let's say here's a negative 3, all right? So so you go from the bottom to the top. So here I am. Okay, I arrive, let's say, at negative 3, and still there is no intersection. So I have nothing yet in the range. And then, of course, I arrive at negative 2. Now, when you arrive at negative 2, well, of course, at negative 2, there's no intersection between the horizontal line and the graph, because there's this circle, this empty circle. So there's no intersection. But just right after negative 2, we're gonna have intersection, right? Like here. So just above the negative 2, we're gonna have intersection, like for example here, right? Or so then my range is gonna start at negative 2. Okay, so again, the range is gonna be on the y-axis. So I'm gonna use the y-axis, okay? Because it's about the outputs y. So it starts at negative 2, but negative 2 is not included because my horizontal line at negative 2 doesn't intersect the graph, because there's an empty circle. So here at negative 2, the negative 2 is supposed to be excluded. Okay, and then I can continue here, like for example, at negative 1, we're gonna have intersection right here. So it's in the range. So we are good. We can continue until we arrive at 0. So at 0, there will be an intersection, right? If you take this horizontal line, so we're gonna have intersection right here. Okay, so 0 is in the range, right? And so we have to include 0. The thing is, I'm gonna stop at 0 because right after 0, there will be no intersection, right? So like here between 0 and 1, you see here, guys, there's no intersection between the graph and the horizontal line. So I have to stop at 0. Okay. You stop at 0, then we continue with the horizontal lines, and then you arrive at positive 1. Well, when you arrive at positive 1, there's no intersection because this is an empty circle. But the thing is, right after positive 1, you're gonna have intersection again, right? So this is here. We're gonna have intersection here, right? So then your range is gonna start at positive 1. Positive 1 is excluded, so that's why I'm using parentheses here. It's excluded because there's no intersection, and you can go all the way up to 4. So when you arrive at 4, well, there's an intersection here. Obviously, if you take this horizontal line passing through 4, there's an intersection here, right? But then you have to stop. We have to stop at 4, of course, because 4. So 4 is included because there is an intersection between my horizontal line passing through 4 and the graph. But then after 4, of course, there will be no intersection. So it's not in the domain. So as you can see, my sorry, not the domain, range. Of course, I mean the range. So as you can see, my range would be so -2. Again, you go from the bottom to the top. Okay, that's so -2 to 0. 0 included, -2 is excluded, and then from 1 to 4, 1 is excluded and 4 is included. Right. So the answer here. So the answer. So the range is so -2. We start at -2, excluded all the way to 0, included because my horizontal line is going to intersect the graph at 0, union, and then we start again at +1, but +1 excluded all the way to 4, included. So that'll be the range. That's the possible outputs you can have here. All right. Any question, guys? So you see how we find the range using horizontal lines. So whenever your horizontal line intersects the graph, then the corresponding value of y is in the range. Okay, so here's an exercise. So again, you go from the bottom to the top. That's really important. Zwana, I see there's a question in the chat. Do we need to graph for homework? To graph functions? No, I mean, if you check the homework, I mean, there's no graphing in the homework, but there are 2 graphs. There are 2 given graphs, and you have to find the domain in the range. Okay, but you don't have to graph any function. There's no graphing in the homework. The graphs are given in the homework. Yeah.
Are you looking for just the points?
What do you mean looking for the where?
So for like f -3, are you looking for us to put it on the points itself on the graph?
Oh yeah, yes.
Okay.
Like what we did yesterday. Remember yesterday we said like f of -3, like -3 is the input, and then you need to find the corresponding output. Yes.
Okay.
All right, so guys, so here's an exercise. You need to find the range exercise. Well, I can do one more example if you want. Let's see. I think, I mean, because it's similar to the domain, but instead of vertical lines, you're using horizontal lines. Well, I don't think you really need another example. I think we can go to the exercise. All right. So, okay. So please try to find the range of the following functions. Okay, so let's take 3 graphs. First graph, oops. So this is my y-axis. Again, this is negative infinity, this is positive infinity. And I'm gonna need a couple of points here. So this is -1, this is -2, all right. And then this is +1, +2, +3, etc. Anyway, so the graph of my function is the following. So let's see, all right. And then let's see. So this is Okay. And then, oh, okay, I'm going to stop here probably. Okay, this is f of x. All right, so this is f of x. Now, okay, this is the first graph. So graph number 2. Again, you have to find the range, right? So graph number 2, this is positive infinity again, this is negative infinity. And then I'm going to need probably negative 1 here, positive 1, positive 2. And then let's say, so the graph, so this is the graph of my h of x. Okay. So this is h of x. Darian, is that the answer for number 1?
Yeah.
Yeah, I think you're correct. Yes. Let me see. Yeah. Well, just one thing. You know, you always go from the smaller number to the larger number. So it's like,
okay.
yeah, the other way. Yes. Yes. Very good. Yes.
So,
correct, guys.
Okay, it would be negative 1 to 3 then.
Yep. Yeah. Absolutely. Yep. So let me just give you a third graph. I'm sorry, guys. I guess probably I need to zoom out here. All right. So last graph, number 3. Oops. All right. So last graph. So I'm gonna need negative 1, positive 1, positive 2. Yes, I think you're correct, Rabio. Yes, absolutely. Positive, negative. And so let's say the graph is the following. So we have something like, so let's say this is positive 2 here. All right, and then negative 1, 2. This is like this here. All right. Okay, guys, this is, let's say, this is a g of x. Okay, so please try to find the range. Let's say you have, I'm gonna give you, let's say 5 minutes, sorry, to think about this exercise. Rabiul, you're saying, actually, yeah, actually, well, just be careful, negative 1, so in number 3, yeah, be careful with negative 1, because if you use a bracket, it means that the negative 1 is included, right? And actually, it's not. So, so for number 3, negative 1, it's not included. But otherwise, you are correct. Yeah. Xing, you're saying, yes. Xing, you're correct. Yep. Yep. Rabiu, yes. Xing, you're correct too. I guess that's your answer for number. Well, you see, Darian, the problem with your answer is that no, actually, 2 is why do you exclude the positive 2? Because you see, if you take a number 3, if you take a horizontal line passing through a 2, you still have intersection on the like on the all right side, right?
Yeah. So it would just be negative 1, comma 2 with the bracket, and that's it.
Nope.
Or no, it would be to infinity. It would
all
be
the
to
way.
infinity, right?
Yes.
Yeah. Okay.
Yep. Yep. Absolutely. Xing, you were saying number 3. No, actually, you don't stop you don't stop at, well, first you don't have to stop at 0 because 0 is included, right? So you can go just like from -1 to 2, right? But then you stop at 2, but you don't have to stop at 2 because you see the arrow here, this arrow, it means that the graph is going to continue all the way up. Okay, it doesn't stop here, so the graph is going to continue all the way up. So like after 2, you're gonna still have intersection. I don't see why you stopped at 2. There are more answers. Lorden, Darian, yes, Darian, absolutely, yes, Lorden, both, yeah, both, yeah, both you are correct, guys. Yeah, both answers are correct. Yes. I'm gonna give you more, a couple of minutes, guys, and then I'm gonna, of course, I'm gonna explain the answers. So for this, well, how much time do you left? 55. We have like, yeah. Well, it depends on how much time we're gonna have after I solve the problem. But then the plan is, so the range, and then after the range, we're gonna discuss there's this notion of x-intercept and the y-intercept, and then I think we're gonna be done with this first section. So yeah, so we are almost there. Um, yeah, I'm gonna say, yeah. So after the exercise, we're gonna talk about the x-intercept, the y-intercept, and then what else? And yeah, and then we are done with the first, and then we can move to the next section. So I think now we are able to do the whole homework. And again, guys, if you have any trouble with the homework, you have any question, you can email me anytime. And if you have still problem, we can meet. You can send me an email to take an appointment. We can meet on Zoom. And otherwise, there's also the online tutoring, right? It's every day from Monday to Sunday, from 12 p.m. to 6 p.m. Okay, so you need to take advantage of the online tutoring. I mean, it's just it's there for you. So it's from 12 p.m. to 6 p.m. every day. Otherwise, as I said, you can just send me an email, take an appointment, and we can meet on Zoom. All right. Probably you're done. I guess. Does anyone need more time? Probably not. Let me see. Okay, I guess not. All right, so, okay, I guess everyone is good. Okay, perfect. All right, so then, guys, so for number 1, you start from the bottom. There's no intersection. There is no intersection, and then you arrive at -1. Right, and there you're gonna have your first intersection. So we start at -1. All right, you start at -1, and then well, you arrive at +1. Well, there's no problem at +1. I mean, we still have intersection. Actually, we do have 2 intersections, not just one. Even better, right? So we don't have to stop at +1 because you have intersection. +2, well, we still have intersection right here. So that's also in the range. So we can continue with the range, and then you have to stop, of course, at the +3, right? So here, +3, there's no intersection, so we have to exclude the +3. So +3 is excluded. -1 is included because we do have intersection. And then, of course, after positive 3, there will be no intersection with the graph. Okay, so the answer here for this number 1, so the answer, so the range is, as I said, you go from the bottom to the top, from the smallest number to the largest number. So it's -1 included, and then positive 3 excluded. Okay, is there any question, guys? Probably not. All right, so for number 2, same thing. Start from the bottom. And now if you start from the bottom, negative infinity, well, we do have intersection, right? Because you're supposed to, I mean, your graph is, it goes all the way down, right? It doesn't stop here. So it goes all the way down. So we do have intersection. That's good. So we can start at negative infinity. You can go all the way up. You don't have to stop at -1. There's an intersection. So you can go all the way up to 1. But then at +1, of course, you have to stop there because after +1, there will be no intersection, right? And so we stop at +1, +1 not included. So we have to exclude +1. So the answer for number 2 would be, like, again, from the bottom to the top, from the smallest number to the largest number. So it's from negative infinity to +1. And actually, both of them are not. Negative infinity is always not included, but also +1 is not included. All right, so finally, last graph. So we start from the bottom at negative infinity. There is no intersection. Okay, and then you arrive at -1 at the level of -1. There's no intersection at -1, but right after -1, you're gonna have your first intersection. So after negative, just right after -1, you're gonna have intersection. So my range is gonna start right after -1. But of course, -1 is excluded. So after -1, you can go all the way up. You don't have to stop at +1. There is an intersection, and now we arrive at 2. Well, at 2, it's included because, I mean, there's intersection obviously on the other side here. As you can see right here, there's an intersection. So that's in the domain. And also after 2, because again, my graph, the arrow here means that the graph go all the way up. It doesn't stop, right? So you still have intersection until, so there'll be intersection all the way up to, all the way to positive infinity, right? So your range is gonna, you don't stop at 2, and after 2 you still have intersection, right? And all the way up to positive infinity. So the range for number 3 would be like starting from negative infinity all the way up to positive infinity, right? And both are excluded. Okay, so that's the answer. That's the answer for number 3. Is there any question, guys, about the range? All right, so I guess not. So it's 44. So we have like, so it's 9:55. So we have like 11 minutes. So in the 11 minutes, we can do at least, I think, we can find the x-intercept, y-intercept. I don't think it's a big deal. It's not. I don't think very hard. So in the remaining minutes, I'm gonna explain the x and y intercepts. Okay, so next, after the domain and the range, so we're gonna discuss the intercepts. So first we have the x-intercept. X-intercepts. Okay, so what's the x-intercept? Well, it's when the function intersect the x-axis. Okay, so the x-intercept is when the function intersect the x-axis. Okay. So for example, so how do you find the x-intercept? So again, so x-intercept, this is like the points where the graph of the function f intersect the x-axis. Okay, so now how do we find the x-intercept? Okay, so first, if the function is given by a graph, so first using graphs. So I'm going to show you how to find the x-intercept. So using graphs. Okay, so for example, so let's say this is here's my x-axis, of course. This is y-axis. So this is -4, -3, -2, etc. -1, 0, 1, 2, 3, and 4. And let's say my graph, my function f of x is the following. So let's say I have the following graph. Okay, so let's say this is f of x. Okay. So the question is, of course, so that's the graph of f of x, and the question is to find the x-intercepts of f of x. So as I said, the x-intercepts are just the intersection. This is where the graph of f of x intersect the x-axis. Okay, so again, so this is just so the x-intercepts. That's the intersection, or the intersection of the graph with the x-axis, or the intersection of the graph with the x-axis. Okay, that's the definition of x-intercept. So like here in this graph, so the question is where the graph intersect the x-axis. Again, the x-axis is the horizontal axis. This is my x-axis, right? So we do have intersection here. So at this point, my graph intersect the x-axis. We do have another intersection here at 0, another intersection here at +2, and another intersection at 3, right? So how many x-intercept do we have? Well, we have 4 intersections between the graph and the x-axis. So we do have 4 x-intercepts. Okay, so we have an x-intercept at -3, at 0, at 2, and +2 and +3, right? So that's well, that's actually the answer. So we have intersection at x equal to -3, x equal to 0, x equal to 2, and x equal to 3. Okay, however, guys, the final answer, we're gonna use the points notation. Okay, so for the final answer, so this is like for the domain and the range, we use the interval notation. So for the x-intercept, your answer, the final answer should be, so we should use the points notation for the final answer. So we have to use the points. So what's the points notation? So I'm gonna just explain it in a minute. I'll use point notation to for your final answer, for your answer. The answer. Okay, so what do I mean by points notation? Well, points notation is when you have points notation is when you have you know, the x and the y so we have like a point. So in the point we have two coordinates. There's the x coordinate, all right, and there's this the second number, so comma, the second number, this is the y coordinate of the point, so the y coordinate. Okay, in other words, so for example, so like in this so for the x-intercept in this case, so what are the coordinates of the first point? So the first point, the first x-intercept is when x is equal to -3, right? My first x-intercept is this one here, x equal to -3. But if x, so this is my point, right? So x is -3. What about y? Well, y is just, you know, the y coordinate, the corresponding y coordinate is just 0. Yeah, absolutely, Lorden. So it's -3, 0. Okay, because this point, the y coordinate is just 0, right? So to find the y coordinate, you have to, or the output y, you have to use the you know, the horizontal line. So the level here is y equal to 0. So this point here, this one here, this is the point -3, 0, because the x, the input x is 3, but the output y is 0. Okay, so what we say that the -3 is the x coordinate and the 0 is the y coordinate. Okay, so my input x is -3, my output y is 0. So so my first, so the x-intercepts here are yes, absolutely, Gordon. So so we're gonna have -3, 0, and then this next point. So you can see here for the x-intercept, because it's the intersection of the graph for the x-axis, then the y, the output y of the x-intercepts, like if you take this point here, the output y is it's also 0, right? So for all the x-intercepts, the y is 0 because that's the intersection of the x-axis. So if you intersect the x-axis, it means that the level or the height y is 0 because you are at the x-axis, right? This is here the y is 0, okay, because the level y is just 0 at the x-axis. So for the x-intercept, the output y is always 0. So so we have the first x-intercept at -3, so that will be -3, 0. Next x-intercept at 0, so then it's 0, 0. Next x-intercept at, you know, x +2, so that's 2, 0. And next x-intercept is 3 at x equal to 3, so that's 3, 0. So what I'm saying, guys, is that for y, for x-intercept, the y is always 0. So this is supposed to be my x, and this is supposed to be my output y, right? So remark here, and I'm gonna stop right after the remark. So for the x-intercept, the output y is always 0. Okay, because it's just an intersection of with the y-axis, sorry, with the x-axis, and so then the y is 0. So for the x-intercept, the output y is always 0. Is always 0. All right, guys. Anyway, so I'm gonna stop here And I'm gonna discuss this again next time. All right, tomorrow, of course. So thank you, everyone. So I'm gonna stop here. I'm gonna stop recording, I guess, and